So switching gears just a little bit, I think what's being changing here across the second half is the recency of the projects. I think like Thomas said, like Cilium Service Mesh was, I don't know, 1 year ago or something. Service Viewer was 2 months ago. And this is what we're going to talk about is negative. We are just beginning to work on it, I would say, across some folks, researchers across University of Washington and Duke University. So we're going to do a series of very short talks. I'll talk about just the overall kind of our perspective on what we are building and how it might work. Dan Young at Duke, he'll talk about this MRPC system he and collaborators have built, and then to make things more concrete, Shangfeng will do a demo of the thing, so just kind of make it more concrete as to what we are collectively building here. So talk about so what is application-defined networking? We'll talk about that. But before that, so this is how we kind of see things. I think, and this has come up, I think one realization is that folks are essentially building full-scale networks across microservices in there. And one of the things we of course know how to build large-scale networks. Internet is one example of that. But over the last kind of few years or 10 years, I think we've just become really good as a community in building networks, right? Like a new data center that has 1,000 tours just shows up every day, and if not even more. However, I think when we talk about application networks, one thing we realize is they're a different beast compared to a standard kind of physical network that you might be building. It aims to connect endpoints of an application, not necessarily everybody. A big difference is what it's trying to do with respect to message passing. So IP does datagram delivery, but here we need rich RPC processing. Earlier we talked about security, access control, load balancing. All the requirements have come up. And the other third difference is this is being built by application developers. So we wanted ideally you'd have abstractions that kind of match what application developers are used to, and not what network engineers with Cisco or Juniper configs are kind of used to in there. And different projects they're all, I think I like them all, they're all taking some kind of perspective on it. And so our perspective in looking at it is that a lot of the challenges that we've been discussing here come from the following one fact, which is that we are trying to design an implementation that serves everybody all the time. So take the sidecar-based instantiation, or take ambient mesh, or take Cilium, or even take Service Viewer. That we think that there's one implementation that can serve all applications and all kind of deployment types, independent of software, hardware that may exist in the environment or not. And as we know from things like system design and end-to-end argument, that implementation will essentially make any such implementation to be practical. It'll make some applications unhappy and will not perfectly fit any given application, because it becomes very, very hard to actually have that general implementation at all there. So we say, how can we actually get that? Suppose we do want a fully custom network implementation for our applications. And how can we offer that perfectly fitting glove to every single application without actually expecting that every application developer implement from scratch their own network? In the past, we've talked about, extensibility and so forth. So this is basically our kind of thinking. Can we actually do one single implementation per application that fits it perfectly, but not require everybody to invent essentially a new network from scratch? So this is where application-defined networking comes in. We think we can do that by decoupling essentially specification from its implementation. In particular, the idea is that developers or deployers of microservices, they can specify what network functions you want at a high level. So this is not YAML config file. This is a programming languages of some sort. Talk about examples with some semantics. And they can specify what the network should do using application relevant abstractions. You can even specify load balancing, for instance, with respect to kind of RPC fields and so forth. And this should be declarative and portable, so the system knows what you're trying to do. Given that specification, our thinking is that a compiler or a controller can auto-generate an optimized implementation of that versus interpreting it line by line. And it can then decide as well what processing happens where, including hardware offload, which things like become very, very difficult today with the sidecar model, but also to the extent that not just what processing happened, we can also determine what message headers go where, maybe in a similar style to, service where things there. So keep that in mind, I think, as a kind of walk through the example, that this implementation that gets generated from the portable specification is custom to what you're trying to do. So example, what that might look like is that at a high level, developer might say, okay, I want between service 1 and service 2, I want load balancing, I want logging, compression, and fault injection. Each of these modules are specified at some high level. So right now, I think our thinking is we can actually build this off of streaming data flow type of abstractions. So in RPC, we look at it at RPC as a stream of data coming in essentially, and we write kind of things that we believe this abstraction is rich enough and it works and offers up opportunities for a lot of other optimizations. We can compile essentially this high level spec down to to eBPF, maybe even to an RPC library, to P4 in some cases where SmartNICs that are P4 based are available, and so forth. And given that core capability, you can essentially do this deployment inside an RPC library or inside the kernel, depending on your compilation target, and you can lay out what happens where. In this case, I could have a load balancer followed by logging, then compression, then fault injection, and I could have decompression on the other side, or I could change the order of things. And the reason I can do that is just the way compilers today can reorder instructions based on data flow analysis, that this is semantics preserving. I can do that too, if there's some benefit to doing that. In this case, I put fault injection first because it's dropping some RPCs on the floor. So it's better to just, drop them early on in the processing pipeline. I can parallelize if I wanted to. Again, semantics preserving because I know what the specification is. I could move things around. The logging, for instance, could be moved from S1 to S2 if there are more resources available there compared to where they are might S1. I could potentially also push things down to hardware. So the model you should have maybe here is something like this is like a TensorFlow kind of thing for where operators have been specified, and you can instantiate those operators at different places, or you can actually compile them down. So in this case, I can do this as well there. Finally, the point I want to kind of make across, okay, like what we're trying to build is that if we decouple the high-level specification of what the network should do, we can generate not just very performant lean implementations. At least that's kind of the thesis. Like I said, we haven't done the work to kind of prove it out, but thinking is that we can actually take all the compiler technology that has worked in other domains, and we can bring it to bear on networking. But we can actually not just do lean implementations. We can do these other things that are not possible today. We can do network upgrades that are completely hitless for the application. And Xiangfeng will show a demo of that, how we might do that. We can easily accommodate new accelerators that come up because we have the spec. What we need to do is a compiler for this kind of new DPU that Intel just released, just as an example there. We can do improved application placement because we know what the application is trying to do as well there. So I'll end there. That's kind of like the thought. We can, of course, chat more later. Happy to take a quick question before I kind of hand it off to Dan Young there. It is interesting to consider this in the context of what I said earlier about XDS being more of an ABI than an API. Every control plane seems to have its own high-level config API that gets compiled down to XDS, and this is specification. Yeah, I think that read is I would say is kind of spot on. I think the challenge here, yeah, I think what we're trying to come up with something that can compile down to mechanisms that already exist and platforms that already exist, and XDS and some of the existing stuff is part of that worldview.
Yeah, I think maybe, sorry, this isn't quite a fully formed thought. I think maybe what I was trying to get at there is that it seems like ultimately you'd want this specification to drive not just the implementation details of the networking for the application, but also like the horizontal scaling and the dynamic control plane stuff that happens after the application is deployed.
Yes, so I think I think that is correct. We were, I think so you were thinking things like, just to be kind of made concrete, like somebody has decided like a new copy of a replica should run, and then networking gets configured automatically for it. Is that things?
Yeah. Yeah, like I said, I haven't really fully thought this through. It was just something that popped into my head as you were describing this. But yeah, that's the sort of thing. I mean, that particular example doesn't seem super difficult or compelling. My suspicion is that there are maybe some more complex examples that we could come up with a little bit of thought that would make it more compelling as to how you could sort of, you know, you're what you're sort of doing, I think, is trying to sort of combine the application's networking architecture with the actual deployment
Yeah.
step, right? We're not
Yeah.
making these separate steps
Yeah,
anymore, right?
yeah. So so I think that example is easy one. So maybe the following tell me, like, I think for instance, one of the things we can thinking about, like you can scale up like these kind of proxies and everything. They're basically middle boxes in the middle of the network, right? So one of the hopes is that we can automatically scale up or down these middle boxes as well. So if you have load balancer or NAT state, so that becomes scalable just in the same way as your microservices become can be automatically scaled up or down. This processing can also be scaled up or down in the basis of knowing essentially the semantics or the specs of the network itself.